Define the term design. Design is an iterative process, which basically the iteration means the multiple number of attempts are made in order to achieve the improvisation or optimization of resources. Resources could be in the form of money, resources could be in the form of power, or maximizing the efficiency of the system also. So all these things are coming or getting consolidated in a single term called as design. Now, let's try to understand the word design from the machine's aspect. So here the machine design is the application of scientific principles. Scientific principles could be in the form of classical theory that involves usage of Newton's first law, Newton's second law, Newton's third law, as well as some thermodynamic laws, as well as the laws related to strength of materials, Hooke's law. All these are the examples of scientific principles. Next is the technical knowledge and imagination to describe and develop the machine or a mechanical system that performs specific function with maximum economy and efficiency. So first point was the usage of scientific principles. Second was knowledge of machine elements, which is more or less associated with the technical knowledge. So how the machine elements are being fabricated and how the shape of the machine elements is being achieved, how the shaping is being done, even that also comes into the part of technical knowledge, and how that the machine elements are joined together, what process is being involved in order to assemble them. And the third point is creativity and imagination. All these information is consolidated to a single place, or where a drawing is made. Through that drawing, the communication is being passed to a person who has made a request or who has given the order to develop some product. So even the drawing is one form of communication. So through drawing and all through drawing, the creativity and imagination can be brought into an idea. Next is, what is the final outcome? The final outcome is, what is the machine serving the purpose, or whatever the component that has been fabricated, is it serving the purpose or not? Next is, all these things that has been done, that is step 1, 2, 3 and 4, it is based on it is done by keeping the customer at the center. That is the very important parameter. So scope of machine design may involve new concepts, improvement of existing machine, enlargement of existing machine, greater capability or capacity, better economy and efficient, economical and efficient performance. Okay, so all these things are involved in the machine design subject. Describe the basic requirements of the design. So what are the requirements before the design process is initiated? So first is that the machine is made up of many number of elements or many number of components. Those components are called as machine elements, and any part which is having a relative motion to another part is considered as a machine element. Each machine element may consist of separately manufactured part. So you can understand here the process which is being employed to manufacture a piston, and the process which is being employed to manufacture a connecting rod or a crankshaft or a casing. All those processes are different from each other, and the product which are being manufactured by different process, they are assembled together in order to perform a desirable function. You could take an example of a roller contact bearing, which is involving the inner race and outer race, and all these things is kept inside some casing. There will be a casing, and between them the rolling elements will also be there. The rolling elements could be in the form of balls or cylindrical roller or taper roller. All these are the examples. So this is an example. You can find the manufacturing technique used for inner race, outer race, cage as well as rolling element is going to vary. Classification of machine elements. So machine elements are classified based on the general purpose and special purpose. General purpose, it could be shaft, couplings, clutches, bearings, springs, gears and frames. So these are most of the time found in many of the machines. Special purpose are, it could be piston, valves, spindle. All these are special purpose components. The objective of the machine element design, it is to ensure that the operating capacity is maintained throughout its service life, and it is minimizing the manufacturing as well as operating cost. Basic design requirements are, there is a list of parameters which needs to be served. So first parameter is strength, rigidity, wear resistance, minimum size and weight, manufacturability, safety, standards, compliance, reliability, maintainability, life cycle cost. So strength is, it is applying or it is associated with resistance, offering resistance when the forces are applied on it without failure. It could be in the form of fracture or yielding. Yielding means plastic deformation. And rigidity is its ability to resist the bending or deflection, especially when it is subjected to twisting loads or bending loads. Wear resistance is the ability to resist the indentation or penetration of one component inside another. Surface penetration, or there could be a formation of dent on the surface, that has to be resisted. So it could be also associated with resisting the corrosion as well as pitting of surfaces, and surface hardening is also required in order to build more resistance. Next is minimum size and weight. It should be compact and lightweight, maintaining the strength and durability. So importance of weight is also very, very important. Reason is that the movability of the machine or a device is more likely when we go for the optimization of weight. Next is, it should be easy to manufacture, cost effective and easy to assemble as well. It should also ensure that the operator's safety is also provided, and if in case of failure, there is a safety feature being added. It could be in the form of interlocks. Standard compliance must conform with the national and international standard in terms of dimensions, materials and grades. Reliability, it should perform under expected conditions over its lifespan. And it should be easy to maintain, or that is to perform service or a repair. And the total cost over the parts life, that is purchase, operation, maintenance, it should be kept at the minimum level. These requirements form the foundation for machine design elements and guide the engineers in creating the components that are efficient, durable and cost effective. Describe the phases of design process. So first step starts with the recognition of aim or a need. Basically, that is the stage when we define the problem. And the second is select the mechanism synthesis. That means the size of the mechanism needs to be estimated, and what is the size of the links or machine components, that is to be estimated. Next is force analysis. Action of forces on the machine component is being analyzed. After that, what is the material that needs to be selected so that we can see that machine or a machine component is working for a desirable period of time. Design of machine elements, that is computation of stresses and determination of sizes based on the material selection. And design modification, that is in order to improvise its functioning, what is the modification that is needed. and preparation of final drawing. So first is that the complete statement of the problem in the form of data indicating the nature, aim, and the purpose for which the machine element is to be designed is framed at the initial state, and study the all possible mechanisms or mechanical group that is required to obtain the given motion, and finding the type of forces on each of the machine elements and transmission of energy from adjacent connected members and how that energy is being transformed, even that is also required to be understood through sketches by showing the magnitude, direction, and point of application of force or torque. Next is selection of material for a given machine element. That is, suitable material should be selected for the machine element and for the whatever the size is desirable or based on the customer requirement. So the material needs to be selected, and the type of loading, it could be static load or dynamic load or harmonic load, and what are all the manufacturing facilities that are available nearby. Next is the determination of size of part and induced stress in that part. So to determine the size of the part, the proper value of the parameter called factor of safety should be considered in the design stress. And the factor of safety is based on the type of material, type of load, manufacturing conditions, and whatever the process, manufacturing process is available. Based on that, the factor of safety is decided. In design of element, it should not deform than the permissible limit. So permissible limit is decided for the deformation. Based on the factor of safety, the working and allowable stresses are evaluated, and it is ensured that all whenever the machine is loaded, it is always maintained under, or we have to maintain it under evaluated working stress. If it exceeds, then the chances of failure are also increasing parallelly. Design modification, that is, sizes of machine elements may be modified according to functional, fabrication, assembly requirements. Hence, the size of the component may be revised on the basis of recommendation given by different committees. And detailed drawing of every machine component to indicate the complete specification and also suggest the economical fabrication process. List the factors governing the design. First one is load, second one is mechanism, third one is selection of materials, fourth one is manufacturing process. So loads, here in the loads, what are all the types of load that are being involved? It could be in the form of tensile, compressive, shear, twisting, bending. All these are categories of load. Next is mechanism. In the mechanism, we try to understand how the motion is being transformed. It is being transformed to circular, or circular to linear, or linear to curvilinear. All these, I mean, basically here it talks about transformation of motion. And selection of material. Selection of material is done on the basis of cost, mechanical properties. There are about 10 to 11 mechanical properties that defines the properties of material. It could be in the form of elasticity, malleability, ductility. All these are mechanical properties, and even the availability of material is also one of the important factors in selecting the material. Next is manufacturing process. Manufacturing process is associated, or the important factor could be what is the surface roughness after the product that has been manufactured. Next would be the cost of manufacturing process, its durability, reliability, safety, and its effect on the environment. Use of relevant Indian standard codes for design. Standardization is defined as obligatory norms, compulsory norms to various characteristics of the product that should be confirmed. The characteristics should include the type of material, dimensions, shape of the component, method of testing, method of marking, packaging, storing of product, environmental conditions, because all these factors are going to directly or indirectly affect the environmental condition and how the product is being disposed to the environment. There are standards even for that as well. The following standards are used in the mechanical engineering design. First one is standards for material selection, chemical compositions, mechanical property, and heat treatment. The second is standards for shape and dimensions, commonly used for machine elements. Standards for fits and tolerances, surface finish of the component. Standards for testing of product, and standards for engineering drawing of the components. Define the screw thread. In a screw or bolt, threads are formed by cutting a continuous helical groove on cylindrical surface. So when you do this, the input motion is rotatory and the output motion, what we guessed, is straight line or translation. So here on the cylindrical surface, if a helical groove is being cut, so when the input motion is given about the x-axis, let's call it as theta x, due to this input motion, the screw or bolt advances in x direction, that is translation in x direction, and this is rotation. Explain the nomenclature of screw threads. So nomenclature, in that we talk about the parameters which describe the geometry of the screw thread, and these parameters or some of these parameters would be also selected for the specifying any information related to screw threads. So let's see the list of parameters. First we have got is major diameter, minor diameter, pitch, lead, crest, root, depth of the thread, flank, angle of thread, pitch, diameter. Now let us see all of these parameters in detail. So very first one, we have got it as major diameter, which is also referred as the largest diameter, and this is also called as nominal diameter, and it is used for specifying the size of the screw thread. Okay, so it is gross or nominal diameter. So major diameter, it is measured, or it is the distance between these two tips of the thread, that is called major diameter. Next is minor diameter. Minor diameter, it is also called as the smallest diameter, or it is associated with the root part of the thread. It is also called as root diameter or core diameter. The relationship between the core diameter and the nominal diameter is given by DC is equal to 0.84 times of D. This is an empirical relation. You have to remember this. And D is the major diameter or nominal diameter, and DC is the minor diameter. So minor diameter, it is the distance, this distance, and major diameter is referring to this distance. The bigger one is the major diameter, and slightly lesser than that is minor diameter. Next parameter we have is pitch. It is the distance between one point on thread corresponding to the same point on the next thread. So it is distance between the consecutive point on two threads. This is the measure of pitch. So this is also one of the important parameters for specifying the thread. Especially you find this in the specification of thread. Very, very important one. Next is lead. So it is the distance moved by the screw when one rotation is given to it. So lead is also expressed as pitch into N. N will be equal to 1 for single start thread, which means for one rotation it advances by one pitch. Same way, if N is equal to 2, then for single rotation it advances by 2 times of the pitch. This is double start thread. Same way, N is equal to 3, that means it is triple start thread. So for one rotation it advances by 3 times of pitch. Next parameter is crest. Crest is the top surface of the thread. This point is referred as crest. This point is referred as a crest. Next is root. Root is the bottom surface of the thread. So here at the lowest part here in the thread, that is called as root. Depth of the thread, it is perpendicular distance between the crest and root. So here you are finding the tips of the thread and this is the root. So this distance will be marked as depth of the thread. Next is flank. The surface joining the crest and root, this is called as flank. Angle of thread, it is the angle subtended between the flanks of the thread. So these two are the threads. These two are the flanks of the thread. Let's say this is one flank and this is the other flank. This is called as angle of thread. So even over here, it is marked over here. So this is the line where it extends and this is the line, another line where it is extended. Next is the pitch diameter. It is the effective diameter where the width of the tooth and the space between the consecutive teeth is same. So here, let's say this is the thread. Okay, I am magnifying them as big triangles. So now the pitch diameter, it is the location where the distances between the space between the two threads, I mean, let's mark this as B distance, and the width of the tooth, this is width of the tooth, let's call this as A. This is width of the tooth and this is called as space between the threads. So pitch diameter is a location where the width and the space are equal. That is, A is equal to B. These two dimensions, wherever they are equal, and the line passing through that will be the pitch diameter. Specification of screw threads. It is given by the standard IS 4218 1976, and the procedure for that is designated. The step 1 is telling the letter M, which stands for metric thread. Next is nominal diameter is included in the specification. Along with that, the pitch is also indicated. Now let's try to understand from an example. So M8 cross 1.25. M stands for metric thread, 8 stands for nominal diameter, 1.25 stands for pitch in mm. Next is various forms of thread. First one is acme thread, square thread, buttressed thread, knuckle thread, and metric thread. So British Standard Whitworth thread, that is BSW. So here you can find the appearance of the thread. It has rounded crest and roots. So this portion is called as crest and this portion is called as roots. And the angle included between the flanks is 55 degrees. And the threads are of coarse type and it is used for the special purposes. Next is British Association thread. So in the British Association thread, it is similar to BSW thread, but it has fine threads. The angle included between the flanks is 47.5 degrees. And it is used for precision work for measuring the instrument and electrical fittings. Next is American National Standard thread. So it is also known as US or Cellar threads. It is having the flat crest and roots. The angle included between the faces is 60 degrees. And it is used for general purposes. Example, bolts, nuts, screws, and tapped bolts. Unified standard thread. So once again, it has rounded crest and the angle included between them is 60 degrees. And this is preferably used in the countries like USA, Canada, UK. Next is Acme thread. Acme thread is strong and easily manufactured than square threads, and it is used for power transmission application, and the angle included between the flanks is 29 degrees. Square thread. It is very strong and efficient kind of a thread, and it is used in power transmission applications like press, screw jack, and vices. And it is expensive to produce. Next is buttress thread. So here in the buttress thread, the power is transmission only in one direction, unidirectional. The angle included between the flanks is 45 degrees, and it is used in the special application. Load is transformed or load is moved only in one direction. Next is knuckle thread. It is a special form of thread and it is used in railway carriage couplings. Next is metric thread. Metric thread is approved by BIS for the threaded fastening. So BIS stands for Bureau of Indian Standards. The angle included between the flanks is 60 degrees. And it is used for general applications. List the different threaded fasteners with legible sketches. First one we have is through bolts. So in the through bolts, there will be non-threaded portion as well as threaded portion. And this is there is nut at one of the end. So it is used for clamping the two plates together. So the body of bolt is passing through the members to be joined and the nut is fixed at the other end. Example could be machine bolts, carriage bolts. Next is tap bolts. So there won't be nut on one side, but it is going to consist of threaded portion and non-threaded portion. And this is used for assembling the two machine parts together. So screwed into a tapped hole of one of the parts to be fastened without the nut. So one of the parts is being fastened or assembled without using a nut. Next is stud. Stud basically consists of threaded portion on both the sides. On the top side as well as on the bottom side, the threaded portion is there. So rounded threaded bar at the both ends. One end is screwed into a tapped hole of the parts to be fastened. Other end receives a nut on it. Example would be cylinder covers, valves, etc. Cap screws. So similar to tap bolts except cap screws. It is similar to tap bolts except that they are of small size. So these are the examples of the cap screws. The angle included is 90 degrees, 120 and 45 degrees for the thread. And variety of shapes for head are available for the cap screws. Different types of tops. From the top view you can analyze different types of heads are there in case of cap screw, and in the last case you are finding the usage of Allen key. Machine screws. It is similar to cap screws with a head slotted for screwdriver. So first one is hexagonal head, Philister head, round head, flat head, hexagonal socket, fluted socket. So all these are the examples of machine screws, but the different heads are being provided over here. And it is generally used with a nut. Set screws. So it is used to prevent the relative motion between the two parts. And instead of key in light power transmission, it is used. It is used instead of key in the light power or light duty applications. List the stresses in the bolt. The stresses in the bolt is due to the initial tightening, external loading, and next is tightening or initial tightening and external loading together. Now under initial tightening, there are different types of stress will be induced in the bolt. The first one is tensile stress and the second one is torsional shear stress. Third one is bending stress. Fourth one is shear stress across the threads. And fifth one is crushing stress. Now, in case of external loading, the threads will be subjected to tensile stress, direct shear, and it next would be combination of tension and shear. So both together. These are the stresses induced in the bolts under the different loading conditions. Design the size of a bolt for a given load. So for tension, we can deduce the expression or tensile loading that can be given by P is equal to sigma is the tensile stress into area of cross section of the bolt, that is pi by 4 times of dc square. The weakest area should be considered. So in short, we will be considering minor diameter. N will be number of bolts. DC is minor diameter and N is number of bolts, and sigma T is tensile stress. Same way, even for shear loading, the formula can be duplicated just by replacing sigma T with tau, that is pi by 4 times of dc square into N. Even the bolts are subjected to direct shear. This is for direct shear. In case if it is torsional shear, then the load P is referred as load over here. So P will be replaced with torque, that is T. So T will be indicating torque over here, and that is equal to tau into polar modulus of the bolt cross section, that is pi by 16 into dc cube. Design the hexagonal and square nut. So first you need to draw a circle whose diameter is matching with the bolt. Next is the dimension S or size across flats, and that is equal to S is equal to 1.25 times of D, that is diameter of bolt, plus 6 or root 3 times of D. So that S should be the distance between the top and bottom edges of the hexagon. And now you need to close the hexagon. And another circle that is to be drawn, which will be tangential to the faces of hexagon. Another circle that needs to be drawn, and that is tangential with the faces of hexagon. Next would be the side across corners. Here the radius of the curvature R will be equal to 1.5 times of the bolt diameter, and this will be taken as height h. So h will be equal to 0.8 to 1.0 times of diameter. And here the curvature should be such that it makes an angle of alpha with the horizontal, and the value of alpha is 30 degrees. And another dimension is there, which is E. The value of E will be taken as 1.155 times of S it is. Same way, even for the side view, it can be drawn. For side view, it will have two curvatures, whereas in the front view, it will have three curvature, and this is equal to S, dimension S. So this is about the hexagonal nut, and in case of square nut, the front view can be drawn. This dimension is equal to E, and this would be H, and the square nut will be appearing like a diamond in the top view. This dimension would be equal to S. The bolt diameter is to be drawn, and another circle that has to be drawn, which is tangential with the sides of this diamond. It has to be tangential to all the sides. So S here will be 1.5 times of D plus 3 mm, and E will be equal to root 2 times of S, and H will be equal to 0.8 to 1 times of D, and chamfer angle, this is alpha. Alpha will be equal to 30 degrees. So this is about the empirical relations for the different dimensions of the nut. As well, for the hexagonal nut we have done it, and for the square nut also it is being done. Design the size of an eye bolt for the given load. Let's take a question on this situation. An electric machine whose weight is 50 kilonewtons is provided with a steel eye bolt for lifting it. The ultimate tensile strength for the steel is 480 megapascal and factor of safety is 4. Find the diameter of the bolt. So the load given is 50 kilonewtons, that is P, which is also 50 into 10 power 3 newtons. Next is ultimate strength is 480 megapascal, which is also 480 newton per mm square. Factor of safety FOS, which is equal to 4. Now safe stress sigma is equal to 480 divided by 4, which is also equal to 120 megapascal. And this is given by, this is also equated with load divided by area. That is, area of the eye bolt will be pi by 4 times of DC square. As there is only one eye bolt used, so value of N will be equal to 1. So now here 120 and load is 50 into 10 power 3 divided by pi by 4 times of DC square. So DC will be equal to 120 into pi by 4. So DC will be equal to 50 into 10 power 3 divided by 120 into pi by 4 raised to the power of 1 by 2, or this should be kept within the root. So upon solving, the value of DC will be 23.03 mm, and the value of nominal diameter, that is D, is equal to DC by 0.84, which is 23.03 divided by 0.84, and that is equal to 27.4 mm is the nominal diameter of the eye bolt. Next is draw the eye bolt showing the proportions. So first is that you need to draw two concentric circles. This is the inner circle, and to the outer circle you have to draw it, but you should not complete it. And at the bottom of this you have to provide some extension or table like an arrangement. And next is the shank portion which is going to have thread over it. Now the proportions are: the size of the outer circle is 3.6 times of D. So these dimensions are usually difficult to remember, and when you are going to use the data book, all this information will be provided, as this is been incorporated according to the Indian standards, or either one or any of the organization will be taking or care of these standards. So inside diameter will be 2 times of D, and this portion of the eye bolt will be 1.36 times of D, and the bottom portion will be 2 times of diameter, and the height of the shank portion is 1.5 times of D, and this will be nominal diameter, that is small d, and thickness of this will be equal to 0.32 times of D, and the distance between the center of eye bolt and this edge of the eye bolt, this distance will be equal to 2.64 times of D. Next, same thing in the side view. The thickness of the eye portion, this will be 0.8 times of D, and this radius or curvature here will be 0.5 times of D. So these are the proportions for the eye bolt. Describe about the self-locking mechanism. Self-locking mechanism is kind of mechanism that resisting unintentional movement of load or machine. This is more or less concerned with the safety. So while ensuring the safety, it could make use of friction or some geometry, or it could be interlocking of surfaces. These things happen generally in worm and wheel mechanism, screw jack, and any mechanism which is involved in the heavy lifting or high power transmission applications. Smart fasteners are those kind of fasteners in which the integration of sensors and IoT enabled, that is Internet of Things, IoT enabled, is present or embedded inside the fastener. Some of the important smart fasteners are sensors, RFID tags, NFC, RFID or NFC tags, microcontroller, for data processing, Next would be battery and energy harvesting system. Explain the strength of screwed fasteners. So here there will be two kinds of failures that are likely to occur. The first one is tearing across at the root of screw threads. So that is given by tearing load, which is equal to PT, that is equal to sigma T into pi by 4 times of DC square, where DC is the core diameter or minor diameter, and DC is given by 0.83 times of D. Next would be direct shearing of bolt, that is P is equal to shear stress into pi by 4 times of D square, where D is the nominal diameter. So bolts are designed on the basis of two parameters. One is tearing and shearing. The tearing happens across the weakest section. The weakest section is nothing but root part of the threads.